Question 3 is asking us to consider a robot that receives a series of rewards in increasing time steps. So reward number 1 is -1, reward number 2 is 2, and so on, all the way up to reward at step number 5, which is 2. And basically at all time steps after 5, the robot gets a 0 reward. Now we've got to try and figure out what's the actual discounted return that this robot can get at various time steps, which we represent by this GO up to G5. We also need to consider that there is a discount factor of 0.5. So there's an easy equation you can use for problems like this called the discount return equation, and it looks like this. For any g at time step t, we have a summation. K ranges from 0 to infinity, and we have our discount factor out the front, raised to the power of k, and then our specific rewards, like this. So whenever we need to calculate the discounted return for a specific g at a time step t, we can just plug it into this equation. And there's a hint down here which says work backwards. So why don't we start with G5 and then work backwards from there and see what happens. So if we start from G5, according to this summation, we're going to have a gamma of 0 and then get reward t equals 5, k equals 0, and we've got a +1. So this will be reward number 6. The next one's gamma equals 1, because the k power raises by 1 on the next round, and we get reward 7. This will continue on and on all the way to infinity, with the rewards increasing and our discount factor going up by a power of gamma each time. Now, what's interesting about this expression here is that actually we haven't caught any of our rewards. The last possible reward we could get is R5, but our expression over here starts at R6. So all of these are actually worthless, and it reduces down to 0. Let's take a look at G4. If we do the same thing as we did for G5, we get gamma to the power of 0, but this time we start at reward 5. But the terms will increasingly go up like, oops, that's going to be 7. But just like for G5, our time steps or our rewards sort of increases by 1 like that. Now, if we look at this equation carefully, and that will go out to infinity, we can see that we can kind of like reduce it down and sub in G5. So this first term here, gamma to the power of 0, that's going to equal 1. So this first term is just going to be reward number 5. If we look over here, reward number 5 equals 2. So we put 2 down here. Now, if we factor out gamma from the rest of the terms, we end up with this expression. That will go off to infinity. Now, if we look closely at this expression in the brackets here, we'll notice that it's exactly the same as the expression up here for G5. So we can see that really G4 is just the reward at step 4, at step 5, plus the discounted value that we got from the previous one, G5. So this reduces down to 2 plus 0.5 times 0, which obviously equals 2. let's do it for G3 now. And you'll see that we actually follow the same pattern again. So for G3, our expression is going to be gamma to the power of 0, R4 this time. And then on to infinity. Now, our reward number 4, we can get the value if we look over here. That's 3 plus, and if we factor out our gammas again, we'll see that we get the expression for G4 in here. R5, R5, gamma to the power of 1 times R6 is the same as this term, and so on and so on. So this reduces down to 3 plus 0.5 times the value that we got for G4, which was 2. And that equals 4. So you can see how by working backwards and using this discount return function or equation, we basically just get the reward at this given time step for whatever G is associated with, and then we add to that the discounted reward that we got from the previous one. So G2, for this one, we should get the reward at time step 3, which was 6. And we're going to add 0.5 plus the value that we got for G3, which was 4. So that ends up being 8. G1 is going to be the reward we get at R2. So that's a value of 2. And we add the discount rate to the value that we got at G2, which was 8. That will be 6. And then finally we have G0. We get the reward at the first time step, and we simply discount back the value that we got for G1, 6. Should be a value of 2. So you can see that there's this nice relationship between the different time steps. And in the end, we get GO is equal to 2. Let's write it over here. GO is equal to 2. G1 is equal to 6. G2, 8. 4. 2. And G5 is 0.